There are two body tracked users, freely expressing bodily motions, and the mobile VR users who has a limited bodily expression. ArithMotion bridges this gap, letting users in such constrained environments respond with peer-relative motion by applying a simple and intuitive arithmetic metaphor. In social interactions, we often make bodily expression in relative to our interacting peers. For example, when a friend waves hands to say hello, you naturally wave back. If you achieve something together and your friend raises hand in joy, you'd likely do the same to share the excitement. We often mirror peers' gestures to show emotional alignment. In contrast, we often make complementary expressions to convey disagreement or adopt an opposing stance. Imagine you are playing a game and your friend wins while you lose. You might respond with a sad gesture while they celebrate. Or if someone threatens you, your body might take a defensive postures in response. In both cases, we react relatively through mimicry or complementarity of the peer's motion. In social VR, users can reflect their own nonverbal expressions on the avatar using tracking devices. As in real life, people in virtual environment also express themselves in ways that are relative to others. However, this is not granted to everyone every time. For example, one may not be able to afford tracking devices, thus only able to use low-cost devices. Or one cannot express bodily motion due to limited space or situational constraint, such as using it in a public space. To complement this gap, current social VR platforms support emotes. However, users are limited to the finite preset, which may not fully capture the dynamic nature of social interaction. In order to allow users to express more socially aligned motions, we focus on the concept of peer-relativity. For example, your friend walks up to you with their arms outstretched. You'd be happy to approach them with open arms, mimicking their gesture. Also, you may choose to exaggerate or restrain motions to adjust your degree of expressiveness based on social context. Conversely, if someone you do not know walks up to you with open arms, you might constrict yourself and move away. Also, you may reinforce your intentions, align with them, or convey new relative intentions by mixing two motions of others. We adopt arithmetic as a metaphor for users to intuitively convey their certain peer relative intentions in constrained environment. We map each relative expression to arithmetic operations, considering the characteristic of each expression. To realize our concept, we first train the recurrent variational autoencoder model to establish the motion latent space. It enables scaling and the addition of motions by calculating embedding vectors based on the user's input. These are examples of motion scaling. We examine that the expressiveness of motion changes according to the scale, effectively reflecting the exaggerate and restrained expression in the generated motion. These are examples of motion addition. It shows the model can reflect the mixed features according to the coefficient set on two motions well in the generated motion. We also developed a negative motion generator, which creates the complementarity of input motion. It first converts to motion to text, and the negative text converter transforms input text to negative text. Finally, the negative text is converted to the motion. We trained the negative motion generator based on the criteria for motion geometry and semantics. For motion geometry, the criterion implies the postural complementarity of the motion. And this is the result of the negated motions for motion geometry. We could observe that the direction of the motion had reversed from the input motion. Next, for motion semantics, the criterion implies the semantic complementarity of the motion. And this is the result of the negated motions for motion semantics. We have confirmed that the negated motion implies the semantic opposite to the input motion. Now, let's see how ArithMotion works in mobile application. First, the user touches anywhere on the screen, simply gauge the avatar slot, then slide up or down to adjust the degree of expressiveness. To negate the pierce motion, gauge at the avatar slot, just like in scaling, and slide left or right anywhere on the screen to select the negative criteria. The original motion and the to-be-generated motion are both visualized in the UI for easy comparison. The last feature, Edition, is designed to support creative motion crafting. By sliding horizontally, they select from their previously expressed motions. By sliding vertically, the user adjusts the degree of expressiveness of each motion. If the user thinks it is done, the user can tap the final motion to save it. Then, the user can express their crafted motion anytime they want, like emotes. Rather than offering this feature as a real-time tool, we envisioned it as a lab feature for applying motion crafting and saving open-ended expressions. We conducted 28-hour-long experiments in realistic social VR settings, where each participant interacted freely with two body-tracked users using only mobile VR device. Our findings suggest that ArithMotion enables users to express open-ended and socially aligned motions even in constant environment, fostering rich communication and enhancing their sense of belonging. For more details, please refer to our paper. Thank you.